Welcome to our webinar on ML-driven identity resolution using Neo4j features. I'm your host, Nathan Greenhut, Head of Accounts for HopsWorks. I have with me today Yogesh Palrekha, who's our Head of Solutions here at HopsWorks. Yogesh is going to walk you through how to scale your AI investments.
Hi, Nate. Thank you. Hi, everyone. This is Yogesh. I'll be going over the webinar today. So this is going to be about how machine learning can drive your identity resolution solution, and also with the help of Neo4j, which is a graph database. So, so let's understand that, what is the role of AI, right? How AI is really driving in terms of, making better predictions and more accurate predictions. And what's the role of HopsWorks when it comes to building any AI-driven, or ML-driven applications. So, this is just a few testimonials from some of our clients who are using the platform today. So our platform, which is HopsWorks, is being used across multiple domains, industries, use cases, and also like different type of problem that we are solving. So we are going to focus specifically on the ML-driven entity resolution system, or the identity resolution system. But as you can see, what companies are really looking for is they're looking for a platform which can handle an end-to-end development of any machine learning driven application, and how they can actually take that application and go all the way from development to production in a very seamless fashion. So we are going to show you what are the features of HopsWorks as a platform, how it can benefit in your machine learning development in terms of the application development, and also what are the benefits in terms of the accuracy, the deployment, and so on. So this is the core problem that we are trying to solve here. So as you know, like I'm pretty sure, like, every organization is having a department which is doing like some kind of machine learning modeling, AI/ML modeling, or maybe there are departments which are having teams, which is more like a disparate approach, where you have multiple teams within different segments of the business who are developing the AI models. So that's one approach where, different teams can actually work in silo, and they can work on the data that is provided to them. They can build their own features, they can manage the features, they can build the models and repository and so on. But, there are challenges, and, I personally faced and worked into this kind of environment, and I feel this is where HopsWorks come to the rescue. So what HopsWorks allow you to do is it's going to bring together all of your application and the feature development in a centralized platform, like one single platform. And that's why we call it a unified platform, right? So your raw data can be in any source system. It can be in an operational system. It could be in a data lake, in a data warehouse, or maybe even in a file system like S3. So what we can do is we can bring together that data, and then also, give you a platform which allows you to build the features, both, with the help of Python APIs, or you can use a low-code platform to build your features. And then using those features, multiple departments or business units, they can actually leverage the same feature values for a given point in time, and they can build their own models. So the whole purpose of the way we are solving this problem using HopsWorks is by providing you a centralized system for your feature development, and then be able to share and collaborate across the organization to build your models in a more unified manner. So that gives you a better consistency and accuracy, and even the efficiency in terms of developing the models. So there are challenges, obviously, right? If you are not using a centralized system or a ML platform, the challenges are obviously multifold. The models that you are going to build are going to be depending on the features which are built in silos. So there could be a feature which is being built in multiple applications, but the definition of the feature may be a bit different, and that can lead to inconsistent values for those features, which can then lead into inefficiencies and accuracy issues within the model itself. So that kind of, really defeats the purpose of, gaining value out of your AI application, because the whole purpose of bringing AI to the application is so that you can have a better intelligence within your application, and you can make better prediction and generate business value. So that's one of the challenges. And then again, you can also, there could be end quality issues where, as I mentioned, there could be inconsistency in the definition of the features. There could be lack of governance, and that can also lead to inefficiencies. So, and then once you have these kind of inefficiencies, then this can further lead into, you don't have a faster time to deployment. So that can actually slow down the whole process of not only maintaining the feature consistently across applications, but also deploying your model seamlessly. So HopsWorks, this is going to be a platform which will modularize all these problems into three different buckets. So we are going to have three different pipelines, which is nothing but the feature pipeline, the training pipeline, and the inference pipeline. And then these pipelines can then be, constructed using the HubSpot platform, and multiple users can actually contribute to this. They can collaborate on this, and they can use all the same definition of the features to build their models going forward. So this not only allows you to build things consistently, but also have a better governance using this kind of platform. And then better governance is going to lead, obviously, there will be less mistakes, and also there will be you will have faster deployment, because now you are using a singular platform rather than using multiple platform, multiple technologies, and different approaches. So the goal here is to make everything better, faster, and cheaper. And obviously, all of this kind of are interlinked, right? So if you want to do a better AI, you want to make sure your predictions are accurate, you are using consistent feature values, and also you have some kind of time travel within a feature data, right? So what if like there is a requirement to go back in time, like let's say 3 months ago or 6 months ago, and build a model using the historical data. So you need a platform that allows you to, that gives you that capability without too much of hustle, where you can just through an API tell the API that I'm looking for a feature data for XYZ version, and it should seamlessly give you that version of the data of the features so that you can build the model and you can do all these experiments. So you need all this kind of, flexibility and different capabilities within your platform to make a better AI application. Again, there are many other features that comes out of the box from the platform in terms of the deployment, in terms of the performance. So your focus is really, you're putting your energy on defining the features, building the models, doing more experiments rather than, trying to play with the technology, because, technology is changing very rapidly and you don't want to lose your focus or get distracted from building your application intelligence. So this platform is going to allow you to not only build your models in a seamless way, but also be able to deploy these models in a very seamless fashion all the way till production, and not worry too much about the performance, because performance is something that the platform is already kind of geared towards. So it's going to give you that horizontal scalability. In fact, it's also going to give you cross-region replication if you're looking for one, where you have multiple data scientists in different regions and they all want to commit into the same feature store. So that can also be achieved because these components can then be deployed across the regions, which can lead to a better performance and better scalability. Overall, by doing all these things in a consistent manner, what you really gain is like, your total investment into building your application is less. You get a better TCO, like a lower TCO, and that's going to make your application development pretty cheap, right? So better, faster, cheaper is really what we are trying to offer you through this platform. We have done some benchmarking of our platform with other platforms that are out there, like other feature store or ML platforms. So these are some of the numbers, and there are different capabilities that we have tested. So you have an online capability where you're reading the features in real time to make real-time predictions. So when it comes to online, we are 12x like kind of faster in terms of, scanning through millions of records and making a prediction in microseconds. When you're looking for an offline feature store, we can give you a throughput of 9 to 10x, and then that's on the read side. When you do a write of the features in an offline mode, we can do up to 6 to 7x. So we want to make sure that we are not only giving you a platform which has got like these features and the capability to develop your applications, but also we want to make sure we are providing a platform that is that is kind of working at the speed and scale that you're looking for, so that your applications do not suffer and you are able to make those predictions in real time at scale on a large volumes of data. So will be sharing these benchmarks. You can go to these benchmarks where we have put in how these experiments were conducted, what systems were compared, like HopSource versus other platforms, and then you can kind of take a look at it and try to understand more on this. So this is the high level overview of the platforms. It's more like I would say a functional architecture. So at the center green box is what the HopSource components are. And then at the top, the blue box is kind of all the applications that are talking to the platform. So the way these applications talk to the HopSource platform is through API integration. So that's one way to integrate to the HopSource platform to be able to make predictions in real time. And then this could be, and there could be a variety of applications, right? So you have the centralized feature store, which allows you to build features, let's say about customers, about accounts, about transaction, your products. So you can have all sorts of feature grouped as feature groups within the platform. And then using these feature groups, you can do a mix and match as well, which is called feature view, and then finally build your model using this feature data. Now you can build different applications. There are some of the examples which are listed out here. We have customer analytics, we have risk analytics, we have fraud analytics. But today we are going to give you a demo on one of the use case, which is identity resolution, and then how identity resolution can help in terms of fraud detection or customer analytics. There could be multiple use of identity resolution. Once you resolve these identities, then you can kind of plug in these outcomes into your machine learning model for various purpose. And there is a collaborative UI too that comes out of the box. So this user interface is going to allow you to manage your feature store, like your feature data, be able to look at what features are available, how many versions are available. You can do a complete auditing and logging, and you can kind of go through all the artifacts that you're creating as a part of your application. At the bottom, we have like the core of it. We have a online store and offline store. Online store is something which can serve you in like microseconds in terms of your response times to be able to make predictions in real time. And then if you're doing something which is more batch in nature, so let's say if you're doing an AML application, which is anti-money laundering, or maybe you're generating offers like for a bunch of customers in batch. So that is something that is going to leverage the offline store. So we bring in both these capabilities in a singular platform. That way you don't have to build two different platforms or two different products for online versus offline, right? so so these are all the capabilities, and then obviously governance comes out of the box. So that's the key thing that we keep in mind, because this platform is really meant for large enterprises, small scale, mid-sized enterprises. It's an enterprise grade platform, and that's why security and governance is all inbuilt within the platform itself. Before I proceed, I'll just take a quick break in case there are any questions. Nate, do you see any questions coming in?
None at the moment, Yogesh.
Okay. So continuing to the slides, this is a kind of a data flow diagram. You can think like that, or a system integration diagram where you have various systems on the left-hand side. These are your source system. This could be data lake, it could be data warehouse. It could be an operational system. It could be an API that you're pulling the data out of from, or it could be like some kind of graph database, let's say Neo4j. So using these source systems, we can pull in the data into HopsWorks, and then you can do all the feature engineering, the model training, the inferences. All these pipelines can be built from start to finish anywhere between like 2 to 3 weeks, depending upon the complexity of application. So you can not only read the data, but you can also perform transformations. And these transformations can be performed using either Python APIs, or we have a low-code accelerator. You have choices on the table, and you can pick one of those depending upon what's your skill level. And then you can also do the predictions as a part of these application development, and then integrate these APIs, which are prediction APIs, into the ML applications. So these applications could be a variety in nature. You're seeing some examples here which are related to customer, risk, fraud, and so on. Also, as a part of this demo webinar, we are going to show you an accelerator, a HopsWorks accelerator, which allows you to configure your application or build your application with low code, no code approach. And today, as I mentioned, we are going to focus on the identity resolution process, right? So let me first explain what is identity resolution, what the problem is about, and how this problem is being solved. So identity resolution could be something related to, let's say you are a large bank and you may be acquiring a lot of smaller banks as a part of it. And each of these banks that you're acquiring may have different customer management system, right? They may have MDM systems, or maybe they have customer onboarding system or KYC system. All of these systems are actually managing their customer data. So what you would like to do is, before you start using this customer data for any kind of feature engineering or maybe a predictive model, you want to make sure that the similar customers or the same customers are de-identified, they are deduplicated, and they are being identified, they are given like a unique entity, okay, unique identity. So, so that's more on the customer side. Similarly, you can also do for addresses, which is more like an address resolution if you want to resolve these addresses. Today, we are going to focus more on the customer analytics. So I'm going to talk more on the customer identity resolution. Okay. So, so now you understand what the problem is about. And you can also have a system where you may not be actually having multiple systems, but maybe there are some loopholes within the system itself, which allows the same customer to be onboarded multiple times. And that's also going to create duplicate customers. So what we do is, before we start building any AI ML application, we want to make sure that if it's going to use customer data, this customer is all, they are all unique. And so that we are able to connect their transactions, their patterns of usage, and so on. So identity resolution or entity resolution becomes really the first step in the process. And that's where we use the power of a combined power of, I would say, the Neo4j, which is a graph database, as well as HopsWorks. So Neo4j acts like a graph engine, which is going to take in this data. We are going to run some graph algorithms like, similarity algorithms to see which customers are similar customers, and we are going to generate scores. Once the scores are generated, then we can apply a cutoff, and then we can say any two customers who has a similarity of more than 95%, they could be possibly a similar customer or the same customer. And then you can kind of look at this data, that what it is resolved into, and you can take an action upon it. Once the entities are resolved, once the customers are resolved, then you can, do all sorts of feature generation on them, right? You can start aggregating their transaction information, their usage pattern, any kind of the chat information that they may be having with the call center. So we can build like a sentiment analysis model and so on. So what identity resolution really provides you, it makes your models more robust in terms of making predictions, because you are treating two customers which are actually the same customer as one customer. And that kind of gives you a 360-degree view across that customer, because if you are treating them as different customers, you may have inefficiencies where you may send the same offer to the same in the same household twice. So that is obviously going to irritate your customer. It's going to be, lack of confidence to the customer, and it's not a good impression, right? That if I'm receiving the same offer more than once, even though I'm the same customer. So we can avoid these inefficiencies, we can avoid the frustration to your customer, and that's going to increase your, credibility in front of the customer. So that's like one of the use case. But if you're doing something like fraud detection, there could be customers who are trying to game the system, where they're trying to create multiple identities or fictitious identities, and then they're trying to do transactions by splitting, and doing like layering. So that's a classic AML use case. So the way you can avoid it, you want to make sure that before you start detecting any kind of fraudulent activity around customer, you want to make sure these customers are deduplicated. They are identified as unique identity if they are the same customers. And then you want to start running your fraud detection system so that you have a, a better view into the customer data in case they are using fictitious identity to split their transactions, right? At the end of that, what we do is, like, once these predictions are made, then we can generate alerts on it. We can kick a business workflow engine where you want to take an action upon these alerts, right? And then if you want to create some kind of investigation system, we also provide you a case investigation dashboard, which will actually allow you to start triaging these alerts, and you can start looking into these alerts. Okay. Finally, we have a dashboarding mechanism within the accelerator, which allows you to build dashboards too. So what the accelerator is really providing, it's a low code, no code accelerator, which gives you these functional components, which you can then use it to build your features, you build your machine learning model, you build an alert engine, entity resolution, case management, and so on. So this is the overall flow or the process flow for this kind of application. So on the left, as you see, there are source systems. The source systems, then we can hook into the source systems using Kafka, which allows you to bring data in real time. Once you bring this data in the form of messages into Kafka, then we can push into Neo4j, which is a graph database. Neo4j is a graph database. It is great to analyze relationships. It can scale to like billions of data points, right? So we can create nodes and edges. So let's say customer is a node, address is a node, and we can start building relationships around it. Using this relationship, we can do multiple things here. One, we can do the entity resolution. This is something that I'm going to demo you today. You can do community detection. You can do fraud detection. So there are different patterns you can find out of it. So you can extract features out of Neo4j, and then you can take these features and pump into the HopsWorks, which is an ML platform, where all the features are kind of centralized. And they're also like, being versioned at the same time. And then you can build your models and algorithms and all of it, and you can do all the predictions out of it. So if you want to do something in real time when it comes to identity resolution, let's say you are trying to onboard a customer and the customer is applying for a loan. So you want to make sure this customer does not exist in your system while you're onboarding as a fresh customer, right? And if the customer already exists, you want to link it to an existing customer, so you have less problems down the line in terms of various capabilities that you're building around the customer analytics. So you can do this in real time, which means you can actually make an API call to a HopsWorks system, which will actually in turn look into the Neo4j graph database. It's going to look for all the relationships. It's going to make sure that this customer does not exist. And if it exists, it's going to return you back a customer ID, which is, and all the details with a matching customer, right? So then you can confirm with your customer if it's the same customer, and you can link this customer to an existing customer. So all this can be done in real time. Also, you can, if you want to try to block, so like in case of fraud detection, you want to block such transactions, you can do that as well. Now, you can build a case management dashboard, which can then be, for your management purpose or investigative purpose. And if there is any kind of feedback, we can take that feedback into the HopsWorks platform so that we can tune these models periodically. You want to make sure that your models are getting tuned, not too frequently or not less frequently, but at a periodic basis. And the frequency of the model tuning really depends on how frequently your data is changing, right? Every industry and every use case has a different frequency of changing the data. So depending upon the volatility of your data, you can decide what should be the frequency for it. So we'll give you APIs which are going to allow you to keep pushing the data, the fresh data into the HopsWorks platform, build your features, and then keep training these models so that you get better performance and better accuracy out of these models, right? So we are not only building a one-time model here, we are actually building a system. And by using HopsWorks as a platform, you are kind of implementing your model in production as you're building them, right? It's not like a re-engineering approach. It's like an approach where you are building right on a production grade system, which you can then take it to the production all the way. Okay. So I think the next, what we are going to do is we are going to get into a quick demo. And before I get into demo, maybe I can take any questions, Nate.
Yeah, there's a question. What types of data, structured, unstructured data, can you bring into HopsWorks?
Yeah, so HopsWorks is it's like a feature store. So you can certainly bring structured and unstructured data. So let's say structured data could be anything that's coming through a database or a file system, like which is more like a CSV data or a tabular data. Unstructured data could be having two flavors. You can have unstructured, like a semi-structured data, which could be XML, JSON files, or maybe like some binary formats like Parquet or Avro. And also, if you want, you can bring unstructured data, which is like completely textual data, because now we have generative AI also on the LLM models embedded into the HopsWorks platform. So you can build your LLM model or these natural language processing models on the platform, which means you can literally bring any unstructured data for those kind of use cases. Any other question, Nate?
None at this time.
Okay, thank you. So let's get into the demo now. And to switch into the demo here. So let me log in into the HopsWorks platform. Okay. So this is the interface. This is basically the backend engine of HopsWorks. So anything you are doing with the HopsWorks in terms of like, building your features, building your models, making predictions, generating feature data, versioning data, the new data that arrives, the online store, offline store, all of this can be visualized from here. So there are a few menus here, and I'm just going to go through each one of them. So feature group is basically all the feature that you're storing in HopsWorks. So let's say if I want to look at my customer features, I can quickly scan through the metadata repository and see anything that has customer on it. So I have something called, let's say, customer summary. So I'm creating summary for 3 years. I have like a couple of features here, like around 50 or so. So I'm taking all the transactional activity that is happening around the customer, aggregating that, and then storing into HopsWorks. Okay. And every time I'm storing, it's creating a new version out of it. So as you see here, this is basically, I'm on version 1 at this point. But if you upload more data or to these existing feature groups, it's going to create basically new versions out of it. So you have a complete auditing and governance within the platform. You can create multiple users. You can do an SSO authentication. Once you log in into the HopsWorks, then it's going to keep a track of everything that's happening in the platform, both in terms of auditing and logging. Okay. So this has got around 52 features. It was committed twice. That means it has been changed twice. And then you can also set some expectations and tags and alerts. So expectations are basically where you can actually create some data quality type of rules. So let's say if I have a field which should contain a numeric value, I can set an expectation around that feature. If there is another feature which is having a categorical variable like a male, female, or maybe a yes or no as a value, then you can kind of create expectation to make sure that the data is conforming to those values. Okay. So data quality is kind of inbuilt. It comes as a part of the platform. And that is where I'm saying that data governance really becomes easier, because the moment you because, developing feature is one thing, but making sure the quality of the data is equally important. And if the data quality is good, your feature values are going to be consistent and over a period of time. Because as you receive new data, you want to make sure that the feature values are not changing drastically. So you can put those controls in place and you can get informed if there is any change in terms of the values or any violation in terms of the possible values within that feature column. Okay, so this is basically going to avoid you to make any mistakes, and then that's going to keep consistency. And then as you are more and more consistent, it's going to give better and better value across your machine learning models. Similarly, you can put tags on it. Tags are basically something, if you tag something that allows you to make your searches easier. So you can tag something, this is going to be my production ready or a UAT ready or a development ready. You can put your phases of SDLC. You can put like tags which are more domains, like, this contains customer data versus contains PII data. So there are different usage of the tags. I would say it's not necessarily meant for one use. You can use the tag concept however you like it, depending upon your process that you're dealing with. And then you can even set up alerts on these things. Like once it kind of, if there is any value which is not falling in line, if there are data quality issues, you can get alerted out of it. Okay. And also we show you the API. So let's say once the feature group is produced within the HopsWorks platform, it's going to give you a code that is ready to go. You can take this code, put it into a Python notebook or Jupyter notebook into a Python world, and then you can start accessing the feature groups, right? So by default, it's going to look at the version 1. If you want to change the version, you can do that as well. And you get two flavors of the API. One is Python, another is Scala. So this is one way of interacting with the HopsWorks platform. Another way, if let's say if you're not Python savvy, or maybe for some reason you don't want to use Python, you want to go through a graphical interface, then we also provide you a low-code accelerator, which allows you to build these feature groups and store the feature groups in the platform. And I'm going to show that as well. Okay. Once the features are created, so let me quickly jump into the accelerator and then show you how I can achieve building the feature group, using a no-code platform or a low-code interface. So once you log in, you can pick like, I'm picking in this case like anti-money laundering. So I'm going to look at some features. So what I'm going to do is I'm going to go to the data science module because we are dealing with machine learning here. And then I can look at my features and then I can create my features into this environment. So this is the same customer summary 3-year feature I was talking about. When you look, you can see all the features. These are the same feature values. So what I've done is using this interface, now I'm able to create my feature groups without writing any code. And I can push data into the feature store using this accelerator, right? If I want to take a look at the data, I can do that as well. So I can take a look at, it's going to go to the feature store, query all the data from the offline store. It's going to display you what values are available within that feature group. Okay. So while that is coming, I can also show you the lineage. So let's say if you want to see how these features were built. So let me go into this. And let me look at the lineage over here. So this is the lineage that we build as we go along. So let's say if you are building features, so these are all the features which are a part of this feature group. And we are showing you everything on the left, how this feature was arrived. Like it is pointing to a data set, it's pointing to a formula. The formula is using like 2 different attributes. These attributes are coming from other data sets. And finally, this is coming through a file. So we can show you a complete lineage from left to right. And this could be really multiple hops, not like 2 or 3. It could be n number of hops, and we can show you complete lineage how we are receiving data to this feature. So this really help you govern your data, govern your feature, and create auditability around how data is moving within your ecosystem. Okay. So Nate, do you have any questions before I proceed further?
Yeah, there's a question. How is this way of doing identity resolution better than what we've been doing before?
Before being traditionally, you mean, right? So I think traditionally, like, people have been using like, functions where they're comparing all the strings, and that's not necessarily a bad approach. But then we are only looking at certain aspects of customer, right? You are only looking at certain properties of customer. That's a traditional way of doing it. And then there is traditionally being done in some kind of RDBMS where you are trying to compare all these strings to each other, and which can take a very, very long time. So what we have done different here is we have built a knowledge graph, which is using the graph technology. I've not gone there yet. I'm still showing you the features. Next step is to show you how exactly identity resolution is being done in the new world, and then how it can scale, because when you're comparing so many customers to each other, you want to make sure that, you're getting better scale. So comparing strings is one thing, and then, using nodes and relationships just makes it, run faster. Like it runs at scale on billions of nodes and edges. So the performance that you're going to get is very different. And the whole approach of building this application through a no code interface is actually going to accelerate. And now also you can look at all the customers that are being identified as similar customer. So let me get into this demo, which can probably answer more around this question. Okay. So I think we we got an idea about like what is HopsWorks and what is the accelerator, right? So HopsWorks is a platform where we are storing all the features, we are building the models, and all of this can be done through the Python APIs as well as it can be done through the low code accelerator. So now let's focus on the identity resolution problem. So, so I'm going to log in into an application here, which is more like a customer analytics, because mostly when you're doing identity resolution, you're dealing with the customer data. So I'm going to go into the customer analytics. And then we have a module called entity resolution. I can get into that and I can define a rule. So let's look at the rule. So we are looking at a customer entity. Um, So you have to first define an entity, right? Before you can create a rule, I'm defining my entity, which is customer, and then I'm pointing to my customer data, where my customer data is, so that when I do entity resolution, it knows where to pull the data from. And then what is the ID, like customer ID within my data? What are the various columns? And then so on. So there are a lot of other features which are kind of, useful when you're using this accelerator. But right now, since we are only focused on entity resolution, the only thing you need to worry about that we need to create an entity, we need to point the entity to the right data set, and we need to identify what's a key column within that data. Now I'm going to create an entity resolution rule, and you can create n number of rules. So this is a rule to resolve my customer. So obviously all my customer data is sitting in this data set. This data is within Neo4j. Okay. This is a data set which is pointing to Neo4j. And I'm kind of saying that, okay, this is a customer data. Customer ID is a unique ID present within the data. It's not unique, but it's unique from a source perspective. In fact, our task at hand is to find uniqueness across the customer and generate a unique customer ID, right? So we are going to use some graph algorithms as a part of this. Now, if you want to filter some data before you actually start the entity resolution, you can do it upfront over here, which means I may say that I may want to only focus on US data and not other countries or other regions. So you can do that kind of filtering upfront, okay? And this could be a reason because you want to just experiment, or maybe you want to implement entity resolution in a specific region rather than going across the globe. You can also put blocking conditions. So you can say that, okay, I want to compare customers within a specific business unit, or maybe between genders. Like I don't want to compare like male and female, or maybe I don't want to compare between country A versus country B. So you can put all sorts of blocking conditions. Once you block it, then it's only going to look within that block. It's like kind of creating a group of customers and then comparing customers with other customers within that group itself. Okay. And now I can create a matching group. So matching groups are basically what you want to compare, right? So I'm saying I want to compare first name and last name. Okay. I want to use some kind of distance function, which is like Levenstein. I can apply some kind of weight. So first name and last name maybe are equally important for me. So I'm giving equal weights. But then you can have some other combination like last name and phone number, and maybe you can choose a different weight over here. You can use a different distance function. A lot of times we might have seen that within first name, last name, you may have like stop words like Mr., Mrs., and you necessarily don't want to compare this because it's only going to take a longer time to start comparing stop words, which are not really useful in any kind of meaningful results. So what we can do is we can apply an exclusion list. So exclusion list is going to be basically, you can decide what I want to exclude. So I'm creating an exclusion list and I'm saying I want to ignore these words, and they can appear, and you can also position them. Like they can say that if it appears in the start of the name rather than the middle or the end. So, or it could be anywhere in this, and it could be an entire word. It can even be case sensitivity. So you can kind of define this rule, and then what it's going to do is it's going to cleanse your data before it actually starts comparing. Okay. And when it starts comparing, it's going to produce the scores, and that is what we are going to look at next. So I have already executed my entity resolution. I'm going to take a look at the results on this. So I had like 1,000 customers. This is obviously sample data. I've resolved them into 34 unique entities, which means I had a lot of duplicate. Okay, because again, this is all fake data. This is just for the purpose of the demonstration. So I can right click and say this particular group is having like 16 customers and they all are alike. So you can kind of right click and get into the details of it. You can also go through the analysis tab here where you can say, okay, I want to focus on customer ID 50,001. And then you can say, okay, show me if this customer has resolved with any other customers. It looks like this particular customer has resolved with like 6 or 7 other customers or 8 customers in this case, and they have all some kind of scores available, right? So it has compared the attributes between the two customers using the graph engine and is giving you a score, a matching score between the two. So most of them has a score of 0.75, some has 0.8. So what I'm going to do is, and some of them has a 100% score. So why don't we take a look into this? So I can right click and say, show me the details. I can open the details and I can see what's going on. So I had two matching groups. This is the first matching group where I'm comparing the first name and last name. So as you see, the first name encountered was this, the last and the first name in the target, which is like the other customer is this. So there's not too much of a match and hence the score is really low. It should be 1 means it's an exact match. But when you look at the last name, it's an exact match. That's why the score is 1. But since we are doing a weighted average score, the overall score is only 0.63. Similarly, I'm comparing last name and phone number, and looks like last name and phone numbers is having a very good match. And that's why we feel that these two customers are the same customer. The moment that happens, we assign them a unique ID, and that unique ID kind of, then can flow into your data warehouse or a data lake or wherever you want to use it, right? In terms of your machine learning application that you're trying to develop. So also I can look at all the components. So component is nothing but when you run the, like, the weakly connected components algorithm within Neo4j, it generates component IDs. Component IDs are nothing but the unique IDs, which are kind of connecting those customers as similar customers. So as you can see that these all customers, they are kind of forming a cluster, and this cluster is all kind of revolving around this customer, which means all of these customers are really the same customer. Again, this is not the real data. So because in practice, you're not going to see like 50 customers are all alike. And again, we are going to generate the score. So you can still apply some kind of cutoff. And then using that cutoff, you can say, I only care about matches which are about 80% or 90%. Once you do that, it's going to filter more. And then you are only going to focus on entities which has a score, beyond that threshold, like 90% or 95%. Okay. So the purpose of this accelerator is allowing you to define your entity, define the rule, define the exclusion list, run the resolution, run this kind of experiment multiple times. And then once you feel that, okay, this rule is making sense, is resolving the entities in the right way, then you can take this output and you can start leveraging for your machine learning application. This is really a precursor before you actually start building your AI ML application. Okay. Because once you have common customers, then when you start aggregating the transaction data and so on, then you get a better picture of it, right? Because I could be the same customer making like having two different accounts and like, and be in the system twice and trying to fake the system or do something, abnormal within the system or trying to do some kind of fraud. So we can easily detect these problems by, by resolving this customer. Okay. Nate, any questions before I proceed?
Yeah, there's another question, two questions that came in. So I'll give you the first one. How does this graph-based entity resolution change existing governance processes? Does it become more automated? What scenarios might need manual governance?
Okay. Yeah, definitely it's an automated. I mean, but the experiments have to be done manually, right? You have to run different experiments with different thresholds, different combination of matching groups. And once you feel that this is making sense, you will start implementing this. Once you implement, it's an automated process. But what I've seen in practice is like, let's say we would say anything that's matching beyond 95% is an acceptable match. So that's like a straight through processing. But anything that falls between 90 and 95, you may want to do some kind of manual intervention, which means you may want to get an alert out of it and then send this alert to an investigator or some kind of analyst who's going to take a look at that data and say that, yeah, it seems like these two customers are same, the system is right, and we can kind of accept it. So there could be a human intervention needed for a particular defined threshold range. But beyond a threshold of 95 or 97%, you can be very confident and you can just proceed, right, without any kind of human intervention. So we have an alerting system that allows you to basically say that, okay, anything that falls between 90 and 95%, please generate an alert. And then anything beyond 95, just kind of resolved as a unique entity. We don't need any more investigation into that. Okay, so that all kind of brings governance as well as, so it really depends on your business process, how your business wants to implement this. What we are giving you is a framework which allows you to configure these aspects of the business requirements. So we can cater to any requirements you might have, uh, in terms of whether you want to fully automate it or whether you want to have a partial automation and then maybe a partial human intervention. Okay, so that's the entity resolution. Once the entity resolution is done, then obviously we can take this data, push it back into HopsWorks. So what we have done is, in a different application that I was talking about, the fraud detection, which is anti-money laundering. I'm going back into the anti-money laundering. And then before I do that, so I showed you the exact the data set, the feature group that was being stored here. So what you can do is using using the accelerator, you can actually create a map, and that map is going to allow you to write the data into the feature group, right? Once the feature is written in the feature store, it's called feature view or a feature group. So feature group is basically grouping all the features. So you may group features by customer, accounts, and so on. And then feature view is basically like creating a database view, right? You can combine few elements from feature group 1 and few elements from feature group 2, bring them together because that is the need of your use case, and create a feature view out of it. So you have both the options. Feature group is more physical in nature. Feature view is more logical in nature. Okay, just like a database view. So this, I'm looking at a feature group. And as I mentioned, I can quickly glance through some of the data. You can also glance the same data from here as well. Okay. And then you can start building your models. So let's say I go back here. I can go and look at all the feature views. These are the feature views we have created for segmentation purpose, because when I'm doing a segmentation, I may want to combine features from two different feature groups. And this is one of those examples. Okay. Uh, Similarly, I can then start building my models and store the models within HopsWorks. Okay, so I see there is a question coming in. Let me take that first. Nate, do you want to read out the question?
Yeah, can I assign different weights to matching different data attributes? Some customer data attributes may have higher significance for matching potentially. Can I change these weights by different use cases?
Yeah, of course. Yeah, so you can do that. You can create different rules, and different rules can have different weights. Okay. And you can also, if you want to combine everything into a single rule, because you may not want to have multiple rules, because multiple rules means you're scanning the same data twice. You can create different groups, and each group can cater to one of your use case. And within that group, let's say it's a first name, last name, you can give a weight of, like let's say 0.5, which is like 50-50. And then you can have another matching group with the same combination, first name, last name, with a different weight on it. So this way we are kind of resolving all the groups for you, and we are storing that result in a database. And now you can access this to make a decision out of it, depending upon which application you're catering to. So either you can create multiple rules, one for each use case, or you can create one rule with multiple groups in it and look at the results to make a decision out of it. Okay. We have inbuilt like the storage connectors, so we can literally connect to any of the RDBMS databases like source system, MySQL, Postgres, Snowflake, etc. We can connect to the cloud databases. We can connect to file systems. So we can connect to any of these databases, or Neo4j database, or MongoDB, and these connectors will allow you to pull the data and start building your features in the feature store. Okay. So we can also do ingestion for you, which means we are pulling the data from source and pushing it into the feature store, right? Once the features are in place, then we can start building models around it. So this is the data that I was talking about. So we can define a model, we can train a model, right? So let's say I want to define a model for suspicious activity, like a gradient boost tree. So here I'm choosing an algorithm, gradient boost tree, and these are all my features that are coming out of the feature store. And then I can say, now I want to train this model. So I can go into the training. So just through point and click, you can do this, or you can write your code like in Python and call all the Python APIs to do the same thing. So we provide you really two different type of APIs. One is like a API with a coding idea like in Python, and a no code API or no code platform, right? So here I'm taking the model, I'm connecting to my feature store, which is in HopsWorks, pointing it to the feature view that I created in HopsWorks. And then I'm kind of saying I'm interested in the feature version. So here, actually, you can choose the version number, like which version you want to train against. By default, it's going to take the latest. But if you want to point to a specific version, you can do that as well. You can define what's my key column, what's my label column. You can map all the features from the feature store to the model, and then you can do the training. While training, you can do a lot of settings here. You can do a hyperparameter tuning. You can save the feature weights. You can save the results of train and test. You can do sampling, and then you can say, I want to store the model back into HopsWorks, right? So now, as you can see here, I have a model registry, which allows you to see the model that is created using the accelerator. So let's take a look at that. So while that is coming, I can also look at the results of the model from here. So I can say, so right now, most of the models are failure. I'll get into a different environment to show you the model results. Okay. So within the HopsWorks, you see these models that are created. I can click on this and I can look at the artifact. You can see there are two different versions of the model already created. You can see all the metrics, like in terms of the performance metrics of the models and so on. Okay. You can also visualize the same metrics through the accelerator. So if you see here, I can go to data science. I can go to the results. I can choose one model from here. I can say, show me a summary, how many rows, etc., the feature importance, which features are more important, the performance metrics, and so on. So either you can visualize all of this through the accelerator, or you can actually go to the HopsWorks engine and you can just look it through the admin panel. Okay. So that's the model development part. Now, the last part is really the visualization, right? Once you build these models, either you want to take some actions by creating a workflow, or you want to build a dashboard out of it. So you can go back to the accelerator, and we have a data visualization where you can create dashboards. So I'm going to look at the default dashboard that's created within the platform. So we have around, I would say, 15 to 20 different type of visualization capabilities, like scorecards, bar charts, network graphs, and so on. And you can build these dashboards out of it, right? So point and click, you can configure your point to your data and then create these visualizations. Okay, so that's the visualization part. So this accelerator is really going to help you to, kind of accelerate your application development journey in terms of pulling the data in, computing, like calculating your features, which means applying some kind of business logic to compute the features, do the data quality checks, and then build the models out of it. Okay. Let me quickly show you the alert generation part. So let me log in back here. Okay. So I'm going to go into the alert generation, the analysis. So let's say we go into the case management. So I've already generated the alerts for you. The cases are generated. And what we can do is, okay, I don't think so I have permission in this environment. Yeah, okay. So now I can look at the alert that was generated. This is basically a case generated on an alert. It's the same thing. And here I can look at all the entity details. This could be your customer information. I can look at the alerts that were generated. This is post entity resolution. Obviously, you want to do something with it, right? You have resolved the customers. This unique customer IDs has made its way into the feature store. And now you want to build models out of it. So we are really looking at an usage of your identity resolution, like what's the next. So we are using the entity resolution output into a machine learning application, which is fraud detection. And then we are kind of looking at those alerts that are coming out of the fraud detection model. You can do a link analysis, which is again connecting back to your Neo4j graph database. And you can see what's connected to this customer. And if you want to see so there's customer and an address and then accounts. I want to see what other accounts this account is kind of transacting with. So I can kind of pop up this graph and see like what else is connected on it. If I want to see any details, I can right click and say show details. It's going to show me all the account details. Okay. Similarly, if I want to right click on transaction, I can look at the transaction details. You can look at how money is flowing between the accounts. So this is more like a Sankey chart for flow of funds. And look at the notes. You can do some documentation. you can do also a workflow engine. This is what I was talking about. So this basically allows you to build any custom workflows. This is another great feature that's available as a part of the HopsWorks accelerator, which allows you to take actions, right? So generating alert is one thing. So let's say you built a great predictive model, you have put the model in production. Now you are generating alerts and you want to take an action. So this could be an ML, like a fraud detection application, where you want to get the case details and assign it to an analyst group, where analysts can come and pick up the case, and then they can start investigating into the case. And then it can go through multiple levels of investigation and then finally close the case. It could be fraudulent case, non-fraudulent case, so on. So you can design this workflow the way you want. You can send notifications, you can call an API, you can do an assignment to a group, and so on. You can be as creative as you want on this. Okay. Similarly, if I wanted to do something like sending offers, so I can generate my recommendations and then send my offers using this workflow engine, right? So the purpose, as I said, the accelerator is going to allow you to build your application end to end, right? All the way from data processing to feature engineering to training and inference and action, and also looking at the dashboards. Then you can look at the history, if any clicks have happened, like anybody has kind of, worked on this case. And if there any notification that has happened, they are going to appear here. Right now, there is no notification set up on this, but you can send emails, text messages, and so on. Okay. And finally, what you can do is you can take all of this and then you can create a pipeline out of it. So we have a pipeline that is kind of automating the whole process for you. Yeah. So this is a pipeline through drag and drop. You can build a pipeline where you're computing the features, you are building the ML model, you're doing predictions, you're generating alerts, generating cases, so on. Okay. So this is the app accelerator that I was talking about. Let me switch back and see if there are any more questions. I'm going to go into the slideshow and go to the last slide. So before I summarize, Nate, are there any other questions before I summarize the webinar?
There's no additional questions right now, Yogesh.
Okay, great. So just to summarize, like what is HopsWorks and how it can help in your, ML application development. So HopsWorks is basically an ML platform. It's a machine learning AI platform, which allows you to bring in your data, build your features out of it in a very consistent manner, give a proper data governance to it, have data lineage around it, auditing, etc. Everything. Everything that an enterprise would need is available on the platform. It can be done in a very consistent manner, efficient manner. And then, obviously that leads into better, faster, and cheaper, right? Because what is going to lead into better, faster, cheaper is not like directly looking at the goal, but how you can achieve that goal. So the goal of this platform is to make sure that you are able to build your applications as fast as possible in a more consistent manner and then have better accuracy. And what we are doing is we are taking all these libraries and putting them together so that you can focus on building the models, building the features, rather than focusing on, integrating the libraries, patching the libraries, and so on. So all of this is kind of available out of the box when you buy the platform. So the platform will come with all these libraries pre-built, pre-configured within it, like a packaged product. And then we are going to release the patches, which is going to keep everything up to date, right? So recently LLM has taken the speed. So we have integrated LLM model into the platform itself. This is going to, definitely save a lot of time and money in terms of developing your applications. And now you can build more apps and faster apps, right? And we are also giving you an accelerator, which is a no-code accelerator, which you can use as a part of your trial or maybe your production application, where you can build applications very quickly. Something that takes like 6 months to 1 year, you can build in like few weeks, maybe like 2 to 3 weeks at the most. That's what we are really claiming. I would really encourage you to reach out to us and give a shot to the HopsWorks platform. And, you can always reach out to Nate. He's available, for any questions. Okay, so back to you, Nate.
Yogesh, thank you. What a great presentation. If anybody has any additional questions, you can reach out to us on our Slack channel, on our website, or email me directly at nathan.greenhut@hopsworks.ai. We really appreciate your time, and we hope you enjoyed the webinar on ML-driven identity resolution using Neo4j features. Thank you, and goodbye.